going to talk about ocean acidification. So since the beginning of the Industrial Revolution, the release of carbon dioxide in the atmosphere has caused the increase in concentration of carbon dioxide. So during that period of time, since the beginning of the Industrial Revolution, the concentration of carbon dioxide in the atmosphere has increased from 280 parts per milliliter till 385 parts per millimeter, and this increase in such short period of time has been the most rapid increase for the past 20 million years on Earth. So why is the increasing concentration of carbon dioxide significant for the oceans? Because 1/3 of all the concentrations of carbon dioxide in the atmosphere is absorbed by the world's oceans. So these two graphs just show the predictions. Yeah, this is from IPCC's report from 1995. Quite old, but then yeah, they show the predictions of on concentration of carbon dioxide for future. So it shows rapid increase here, and the predictions also for pH value of oceans, which shows decrease there. So the absorption of oceans, absorption of carbon dioxide from the atmosphere is significant for people because it causes it decreases the effects of climate change. If it decreases the global warming effect. However, it doesn't have positive effect on the marine life. So what is happening? CO2 dissolves in water and carbonic acid is being produced. So as there's more CO2, greater concentration of H+ ions is present, which causes decrease in pH of seawater. So since the beginning of the Industrial Revolution, the pH of ocean has changed dramatically. So it has decreased for about 0.1 units on average, so from 8.23 to 8.1 units. And estimates, so predictions that scientists are making say are not optimistic about this. They also say that concentration of CO2 in the atmosphere in the next 50 years is going to reach the point of 500 parts per milliliter, parts per million, I'm sorry. And till the end of this century, the number is going to rise up to 800. So, okay, this graph shows the levels of carbon dioxide in the atmosphere. So before the Industrial Revolution, at now, and these two are showing the future predictions. So as we see a dramatic and its effect on coral calcification rate, so it's gonna decrease dramatically. Why? Because okay, this summarizes what I've just said. When CO2 reacts in water, it also reduces availability of carbonate ions, which are important for formation of coral reefs for some marine organisms, such as corals, plankton, and shellfish. Some of the smaller calcifying organisms are very important for the as food resources for higher marine organisms, and declining coral reefs due to increases in temperature and would have a negative impacts on tourism and fisheries. So that's how a human society would be directly affected by the decrease in pH value.
Okay, this is a graph that just shows how the pH has stayed really stable for the last about 25 million years, and there hasn't been a great increase as we can see. Okay, I don't know how to use this. And so it's never been higher than 0.1, even during glaciation, and there's no evidence that it's ever been lower than 0.6 units below the pre-industrial time. So as we can see, it's not that so much that the pH, or it's actually not acidifying, it's just decreasing in alkalinity. So the ocean is still alkaline, but decreasing. And it's not exactly that it's going down a lot, but that it's going down quickly. So this graph shows the similarity in the increase in carbon in the atmosphere and the decrease in pH in the ocean. So ocean acidification also isn't just a result of climate change. It's not a result of climate change. It's a result of increased carbon. So they're two different effects of the same emission. And these are from stations in Europe, Hawaii, and Bermuda. And I think these are some of the main stations where they have been measuring ocean acidity or alkalinity. And this is really interesting, I think. There's something called a saturation level, and it's to do with the level of available carbonate. So the top layers are supersaturated and the bottom layers are undersaturated. And basically, as pH decreases, little phytoplankton called, some of them are coccolithophores. This is really random, but the white cliffs of Dover are made of coccolithophores that have like built up over a really long time. Anyways, that's cool. But so as the alkalinity decreases, these organisms can live at lower. They have to have higher and higher pressure, or lower and lower pressures. So basically, as alkalinity decreases, they can't live deeper, and so the volume that they can live decreases. And this is a prediction for the saturation levels of 2100. And as you can see, in the Arctic, even there's extremely low conditions for growth, and even in the tropics, which right now are really optimal areas for growth, it's just moderate. So, but we also don't really know if these phytoplankton can't, basically but they can't get enough carbonate out of the water to make their shells, and we don't know what the effect of them dying will have on the greater marine population, because they're the base of the food chain.